Hello all. Won't be here again today for, I'm actually going to be in a meeting. So I'll be available by email if you do have questions, but I wanted to go over this last little bit before your exam on stoichiometry. It's called percent yield. It's essentially the efficiency of a reaction, basically how much of a reaction actually reacts, how much of it goes through, and how much that gets produced actually gets produced as opposed to what should get produced. So what we've been doing with the stoichiometry is calculating theoretical yield. So this is how much should get produced in a reaction, but never ever will it be 100%. What actually comes out is what we call actual yield. This is what gets produced in an actual reaction, and we divide what we get by what we should get, and then multiply that by 100 because it is a percentage, and that will give us our percent yield. Never should it be over 100%. If it is, something went wrong. And it really shouldn't be really low percentages either. If it is, something calculation-wise probably went wrong. So somewhere in the middle is what you're looking for. Significant figures will apply on this just like they do any other time. So let's kind of look at this and get started. This equation is already balanced. You need to make sure it is balanced first, but this one is. So in this one, I began this reaction with 20 grams of lithium hydroxide. So we're going from lithium hydroxide. What is my theoretical yield of lithium chloride? So we're converting grams of lithium hydroxide and we're trying to get to grams of lithium chloride. So our basic stoichiometry equation, nothing new here. We first have to convert from grams of lithium hydroxide to moles of lithium hydroxide. And so 1 mole of lithium hydroxide okay, so we need to find the molar mass of lithium hydroxide. Lithium on the periodic table is 6.9 and some change, so we're going to round that to 7. Oxygen is 16, and hydrogen is 1. So 7 and 16 is 23, plus hydrogen's 1 is 24. So remember, keep these as whole numbers, just to make the math easy. Next, we go from moles of lithium hydroxide to moles of what we're looking for, lithium chloride. And on our equation, this is a 1-to-1 ratio. Then we've got to get back to grams. So 1 mole of lithium chloride will be a certain number of grams of lithium chloride. And lithium is 7, like I said earlier. Chlorine is 35, so we're going to have a total of 42 grams. Cancel units. And then now we do our math. We have 20 times 42 divided by 24. And we started, this one's a little iffy, but we're going to call it 2 significant digits. I realize it's actually not, but it's what I want, and I should have changed it, but I'll do that next year. So 35 is my answer. That's 2 significant digits, so that's what we're going to go with. So that will be my answer for my theoretical yield. It says I actually produce 6 grams of lithium chloride, so I'm going to put that in this equation. So 6 grams is my actual yield. 35 is my theoretical, what I should have gotten, and then we're going to multiply that by 100. Because when I do 6 divided by 35, I get a decimal. And so we always have to multiply by 100 so that we get a true percentage. And we're going to round this to 2 digits. So 17% is what we're going to end up with here. So not a very efficient reaction, but that's what the math comes out to be. The other example, we'll just do this other one and then we'll be good. This one, you do have to balance, so we need to keep that skill involved. So we'll start with iron. Iron is 1 here, but 2 over here. So we need to make this 2. and that gives me 2 PO4s. Over here I just have 1 PO4, so we're going to make that 2. That gives me 6 sodiums. Over here I have 2, so I need to make it 6 also. And then that gives me 3 SO4s. Over here, SO4s are already 3, so I can just leave that as a 1. So you got to balance first. And so we've got to do stoichiometry. This one is asking us to go with 25 grams of iron 3 phosphate, which is this one. Excess of sodium sulfate, that just means that everything here provides all I need to react that. And also how many grams of iron 3 sulfate, this one, are produced. So we set up our equation. And we have to sorry, I lost my train of thought. We have to convert from grams of iron phosphate to moles of iron phosphate. And on the PowerPoint that I had, this was actually given, but on the paper it's not. So iron, let me check that. Iron's mass is 56. P, phosphorus's mass, is 31. And then oxygen is 16 times 4, that's 48. So altogether, we're going to have 151 grams of FePO4. That's our molar mass. Next, we go from moles of FePO4, to moles of what we're looking for, and it's Fe2SO4 3. And so according to our equation, it's 2 moles of iron 3 phosphate to 1 mole of iron 3 sulfate. And so now we go to grams of iron 3 sulfate. That's what we're looking for. So on bottom we have 1 mole of Fe2SO4 3. And then we're looking for grams of Fe2SO4 3. And just because I've done this a couple times, I know that that's 400. You can add it up, 2 irons, 3 sulfurs, and 12 oxygens. We'll then cancel out our units, and then do a little bit of math. So we're going to start with 25, multiply that by 400, and we'll divide by 151, and then divide again by 2. And that gets me 33.11. And the only number I'm given was 25, and that's 2 significant digits. So I need to make my answer be 2. So we're just going to go with 33. We'll write it up here real tiny, kind of ran out of room. And that's grams of Fe2SO4 3. Sorry for the tininess there. So that's 33. That's my theoretical yield. And then finally, it says if 18.5 grams of iron 3 sulfate are actually produced, when I do this reaction, what is my percent yield? So we're going to take the actual, divide it by our calculated 33, multiply by 100. Don't forget that. That's very important. So we're going to take 18.5 divided by 33, and I get 0.56 times 100. I get 56.06. And so I use 2 digits here, 3 there. We go with what's less, so 2 digits, and that is going to be 56%. So on the review, I go over this as well, how to do it. The test will be a lot like the review, but this is what I'm looking for. I want to see all your work. I want to see a number with significant digits correct, and then the units that it asks for. And then for the percent composition, or percent yield, excuse me, I want to see the actual, whatever it gives you with a unit. I want to see the theoretical, either if it gives it to you or it's calculated with the correct number of significant digits and the unit, times 100, and then equals an answer with the correct number of significant digits that's indicated, boxed or circled preferably, but that's how I want this done. So if you have questions on percent yield, please email me. If not, if you get it, fantastic, move on. Our test will be the next time I see you, the next class. So please prepare yourself and let me know if I can help out in any way.